Hello, good day everyone. In this video, we are going to tackle about limits of transcendental functions. In this video, we will be evaluating limits of transcendental functions. But before we c- proceed with evaluating, let's determine and define what are transcendental functions. These are functions that cannot be expressed as a sum, difference, product, or quotient of algebraic expressions. The term transcendental means that the function is not algebraic. And with that, let's try to consider an example. And let's recall first this definition. If b is greater than 0 and b is not equal to 1, the exponential function with base b is defined by f of x is equal to b to the x, where x is an element of a real number, and b, we let b greater than 0 and b should not be equal to 1. If b raised to y is equal to x, then y is called the logarithm of x to the base b, denoted by this function. Y is equal to logarithm of x base b. And here we go with the first. We consider the natural exponential function f of x is equal to e to the x, where e is called the Euler number or Euler number and has value 2.7188281. You can double check using your calculator. Just press there, alpha, and find the symbol E, and you are going to get the same value, which is 2.718281, and so on. Let's now evaluate the first limit. Given the limit of e to the x, where x approaches 0, or as x approaches 0. Let's construct table of values. We start by approaching the number 0 from the left, then from the right. Why are we going to approach 0? Since, as you can see it here, that the value of our c is equal to 0. Therefore, we approach to 0 from the left, then from the right. Let's start with approaching 0 from the left. So this is an automated table already. So in order for you to determine that a value is from the left of 0, you're going to create or imagine a number line. So you have it there. Before we reach 0, there is -1, 0, 1, 2, right? And with that, we are going to choose -1. Why? Because -1 is a closer number to 0. And in order for you to find the value of your f of x, just simply substitute your value of x to your function, which is e to the x. So if you substitute -1, that's e to the -1. You can use calculators in solving the value of f of x. So when you have e to -1, that's equal to 0.36787944117. And same goes with the other value of our x's. So as you can see here, the other value of x's are very close to the value of 0 here, right? So This is our x. So as x approaches 0, the value of our f of x approaches 2. As you can see, what should be the number? It approaches 2. Here we go. Intuitively, from the table, as you can see it here from the table, as x approaches 0, the f of x is getting closer to 1, or the value of our f of x is getting closer to 1. So that is how we conclude this given table, where our table is approaching 0 from the left. How about approaching 0 from the right? So when our value of our, since our value of our C is 0, I chose 1 because if you imagine or if you create a number line, 1 is on the right part of 0. And in order to solve for your f of x, as you substitute the value of your x to your function, which is e to the x. So when you substitute e to the negative 1, that's equal to 2.71828182846. There's no need for me to elaborate more on the other values of x. You can double check these values using your calculators, okay? Just simply change the value of your x from 1 to 0.5 to 0.1 and so on to 0.00001. This value is very much closer to 0, right? But still, it is not yet 0 since we have 0.00001. And as you observe here, we have 2 until 1. And intuitively, from the table, as x approaches 0, the f of x is getting closer and closer to 1. And this is how we see it included by the answer 1. Since our one-sided limit as x approaches from the right and another one-sided limit as x approaches from the left, both of them are equal, therefore our limit exists. Then and that is equal to 1. And this is our final answer for example number 1. This is how we graph y is equal to e to the x, or the function e to the x. And we will have the same observation that as x approaches 0, as you can see it here, these are the value of our x. From the left, as x approaches 0, our f of x or our y approaches or is getting closer and closer to 1. And that is how we show the graph. Let's have another example. Let's evaluate the limit of logarithm of x or log x as x approaches 1. So take note that the value of our c here is 1. We first approach 1 from the left. So to make it systematic, we always start from the left and then the second one should be from the right. So it's up to you which part do you want to approach. You can start from the right or you can start from the left. In my case, we first approach 1 from the left. And this is how you can see the table as you substitute first our value of x, which is 0.1 is located from the left of 1. And when you substitute that to your function, which is the log x, You can use your calculator, and if you have log symbol in your calculator, the better. Just press log 0.1, enter or equal, press the equal symbol, and you will get -1. That's just how easy it is. The log of negative, or the logarithm of negative of, I mean, 0.1, that's equal to -1. That's for the f of x. Same goes with the values of our x's here. 0.5, you will get this. 0.9, you will get this value, and so on as this value. 0.99999 for the value of x. Our f of x is -0.000434296. To solve for f of x, you can use your calculators in substituting the values of x to the function. And that's the easiest way to solve for our f of x, by using our scientific calculators. Now that we're done approaching from the left, the next one will be approaching 1 from the right. We all know that 2 is on the rightmost part of 1. Then I chose 2 as my starter value of x here, as you can see here above. And then my last value will be 1.00001. If you're asking, sir, isn't it equal to 1? No, 1 is not equal to 1.00001. They differ in their value, especially here from its decimal point. Because when you say 1, that is just equal to 1.0. And when you substitute the value of your x's to your function, the same function, the logarithm of x, you're going to get these values of f of x. You can double check if I input, or my inputs of my f of x are correct. You can double check all of it from here, here, and here, and here, and so on until the last one. You can double check that one by using your scientific calculators. Observing from the tables, we can say that as x approaches 1, so you can say x approaches 1, the value of f of x get closer and closer to 0. And from our first one-sided limit from the left, and this is another one-sided limit from the right, and they are equal, therefore our limit exists. The limit of the function exists. And this is how we write it. The limit of the logarithm of x as x approaches 1 is equal to 0. And we should box our final answer. Observing from the table, we plot here the graph. So you can see it there. This is the graph of our f of x, which is equal to logarithm of x. So the same observation as x approaches 1, the value of our x, so this is the x value, right? If it approaches 1, look at here, 1, this is the 1 of x. Our f of x is getting closer and closer to 0. And this is how we illustrate the table. You can use online graphing calculator to double check whether the graph is correct or not, because we nowadays it's very convenient to double check using online graphing calculators. There are a lot of graphing calculators that will guide you whether your graph is correct or not. Let's have another example. Evaluate the limit of sine x. Now we are having trigonometric function. Sine is a trigonometric function. The first one is an exponential function. The second one is a logarithmic function. And this one is a trigonometric function. Since there are only three types of transcendental functions, let's evaluate the limit of sine x as x approaches 0. Now we start with the table or table of values approaching 0 from the left. And this is the table, or this is how the table looks like. Uh-huh. Since -1 is on the left of 0, so I started with -1 and ended with -0.000001. In order to find the value of our f of x, please take note that in finding the value of x using calculator, make sure that you are in radian or rad mode. You can press mode and look for RAD or radian mode in order for us to solve the exact value of our f of x. If you're asking, why is it like that, sir? Why if I'm using degree, will I get the same uh, answer? No, you will not get the same answer. You should use the mode rad. Remember that our trigonometric functions are always labeled in radian. And you can double check again if my values here are exactly correct. Yes. And now let's approach 0 or approaching 0 from the right. So here is the table approaching 0 from the right. Knowing that 1 is located on the right part of 0, so I chose 1. Since 1 is very close to 0 and approaching it from the right, so we go to 0 or we approach our x approaches 0 here. So from 1 to 0.5 to 0.1 until 0.00001. And here is the value of our f of x. Just the same process as you substitute the value of your x to your function. That's sine 1 and press equal. You are going to get 0.8414709848. And that's how easy it is. Based from the tables, we can say that as x get closer to 0, or as x gets closer to 0, the values of f of x, the values of f of x get closer and closer and closer to 0. As you can see, look at, as you observe here, the values from 0, 0. This is 3679s, right? Here that we already have 6 9s and so on, 5 9s until the remaining digits in our decimal, that's 0.000. So which means we get closer and closer to 0. And that's how we observe from the table. Therefore, the limit of sine x as x approaches 0 is equal to 0. And that's our answer. Looking at the graph, this is how we graph trigonometric functions. Yeah, yes, I am using here radian measures, right? That's why I'm talking to you earlier that in solving for the value of f of x, the mode of our calculator should be in radian. As you can see here from -pi to negative 1 half pi until 3 pi, which means that's a rotation of 1, 2 pi is our first rotation of the circle. Remember that 2 pi is equal to 1 circle, right? But we started with negative pi. So this is 1, 2. That's 2 circles all in all if you're going to do it in a circle way. But this is in a graph way, in a two-dimensional graph, as the values of our x approaches 0, which means as we approach 0, this is the 0, right? The values of our f of x, as we approach 0, the values of our y or f of x get closer and closer to 0. So it is here. And this is how the graph looks like. In guiding your graph, in plotting it in an online graphing platform, you can simply input the function of the limit. And that's your guide to determine whether the values of your table, as you plot it in a graphing paper, or as you graph it, it will have the same graph. The purpose only of an online graphing calculator is to double check and to make sure whether your graph is correct or not. Now let's proceed to some special limits. Yes, in limits we also have special limits. And let's start with the first one. Let's evaluate the limit of sine t over t as t approaches 0. If you're asking, sir, why are you not using x? It's okay as long as you are using any variable, and it should be uniform. In one function, you should use uniform variable. If you're using t, then it should be t all in all, not sine t over x. That's not allowed because you are using a different variable, and that makes it confusing. Let's start with the first table, which we will be approaching from the left, or approaching 0 from the left. Let's start with negative 1. We know that negative 1 is on the left part of 0. And then, as you substitute negative 1 to the function, that's sine negative 1 over negative 1, you will get the value 0.84147099848. And with that, please take note again that using calculators in solving the value of f of t, make sure to set the mode into rad or region. Just press shift mode. It depends on the calculator's function. Others will just simply press mode and then choose the rad. And other calculators, you need to press shift mode. It depends on the calculator. And you can double check whether my values of f of t, f of t, are correct here. So for example, this one, that's simply sine of negative 0.0001 over negative 0.0001, and you will get this value. Now let's approaching 0 from the right. I'm choosing 1 as my first value from the right, and then getting closer and closer to 0. As I substitute 1 to my function, that's sine 1 over 1, and that's equal to 0.84147099848. Same goes with the other values. You can double check whether the inputs I have here are correct. And both tables show that as f of x is approaching to 1 from the left and right, what I mean here is as f of t is approaching to 1. Okay? So in stating it, that's as t approaches 0, f of t is approaching closer and closer to 1. And that's for both from the right and from the left. Okay? I am just rephrasing this statement here above because it lacks the t. And we need to use f of t here. Take note for that one. Okay? That's only a typo error. And therefore, we can say that the limit of sine t over t as t approaches 0, it's equal to 1. And that's the answer for our second example for some special limits. And this is how the graph looks like. Just input y is equal to sine t over t in any online graphing calculators, and you can see this graph. And that's the same observation. As our t approaches 0, our f of t approaches to 1. This is our t, which is the x value, approaches to 0. As we approach to 0, our f of t approaches to 1. If you're asking, sir, why is it hollow? It should be hollow and not shaded because if you're going to substitute a certain value or when you substitute 0 here in your denominator, that makes it indeterminate, right? But we are graphing it. We are not solving it algebraically, or we are not solving it by its equation. That's just through substituting values of x and finding the value of f of x. Therefore, our graph should look like this, and then the point here, which is 0, 1, that should be hollow. Take note for that one. It should be hollow. Now let's evaluate the limit of 1 minus cos t over t as t approaches 0. And again, let's start with the first table as we approach 0 from the left. And this is how the table looks like. I chose -1, and then in finding our g of t, make sure that the mode again is in radian since this is a trigonometric function. And you can double check whether my values here are correct. Now, approaching from the right, this is what the table looks like. So uh, I solve it first for you to determine and you just double check it, whether the values I input here are correct. When t is 1, since 1 is located from the right of 0, so I choose 1 and then getting closer to 0. And these are the values of our g of t. Tables shows tables show that as t approaches to 0, g of t approaches closer and closer to 0, right? Is if we approach 0 here, we also approach 0 here. And that's how we state our observation from both tables. Remember that both tables are equal. They are approaching their g of t from the left and from the right are approaching to 0. And if you're asking, sir, what if from the right and from the left they don't have the same value of g of t? I mean, they don't. You mean as they approach 0, and then they will have a different value. For example, our from the left, we approach to 1, and from the right, we approach 0. We are going to state that the limit does not exist if they will not be equal. We can only state this limit of 1 minus cos t over t as t approaches 0 is equal to 0 if both one-sided limits are equal. And if they are not, then the limit does not exist. Okay? And that's our final answer. Here is the graph. Okay, just the same as t, or this is the value of x and this is the value of f of x. As t approaches 0, so this is our t, as t approaches 0, our g of t approaches closer and closer to 0. So it's located on the origin, and you need to take note that it should be hollow. Why? Since if you're going to substitute the value of our t to our denominator, remember that it will make the function undefined, right? Since it makes it undefined, so that's a hollow portion. It should be a hollow portion because we are only graphing here based from the table. Now let's have the limit of e to the t minus 1, or e raised to the power of t minus 1 over all over t. As t approaches 0, let's start with the first table approaching 0 from the left. And this is how my table looks like. I chose t, then this is h of t. If you're asking, sir, you're using a different letter, it depends on you. You can use f of t, you can use g of t, you can use y of t, as long as that represents the function or from the variable t, and our inside the parenthesis or the letter inside the parenthesis should be the same with here. Since this is an Euler or Euler's number, that's E, right? So you just simply press there when we substitute -1, as you substitute -1 to our function, that's alpha E raised to the power of -1 minus 1 all over -1, and you will get the same number. That's 0.6321 and 1205588. And if you're asking, sir, the mode should be in degree or radian? That's a good question. The mode should be in degree because we are not now using trigonometry. This is not a trigonometric function, so it should not be in radian. Radian measure are only specified for trigonometric functions and nothing else. Just double check whether my values here are correct. And if not, you can raise a question. You can clarify things through the comment section or after the video. Now let's proceed with the table approaching from the right. This one is approaching from the left, and this one is approaching from the right. We approach 0 from the right, and 1 is on the right of 0. Now I substitute each t starting with 1. That's e raised to the power of 1 minus 1 all over 1. Okay? And be careful. You must be careful in substituting in order to solve the same value. You can double check using your calculator whether my values here are correct. And therefore, tables show that as t approaches 0, as t approaches 0, our h of t approaches closer and closer to 1. And we can say that the limit of e raised to the power of t minus 1 all over t as x approaches 0 is equal to 1. because they have the same we have the same observation from the two tables from the left and from the right. That's why our limit exists. And if you are going to substitute the value of x to our denominator, that makes it undefined, right? Therefore, in our graph, there should be a hollow part. As x approaches to 0, our f of x, or as t approaches to 0, and our h of t approaches closer and closer to 1, and it's here. That's why I label it there a hollowed circle to represent that substituting the value of our c to the denominator, that makes it undefined, which means there is no function there, or the function is undefined, so that's hollow. Okay, we conclude that these three special limits will result in an indeterminate form. Again, will result in an indeterminate form that results 0 over 0 upon direct substitution. So that's what I mentioned earlier. When I substitute the value of x to our denominator, that makes it 0. They are not resolved by factoring or rationalization, but by a method which you will learn in college, calculus. Since you are enrolled first and you're learning it first here in basic calculus, we are not going to discuss further about that. But you're going to discuss this method when you learn in college calculus. Now let's have a practice exercise. It's your time to evaluate each limit by constructing its table of values. You can pause this portion here. You can compare your answers and you can double check the graph to any online graphing calculators and make sure to label it well, whether it is hollow or not. But in our direction, we are just only going to evaluate the limit by constructing the table of values. So there's no need to graph here. And that ends our discussion. We ended with a quote that know your limits and make it as the fuel of a positive change by Anonymous. Thank you so much, everyone, for listening and participating here in my video.